So now we'll get a little deeper into the different aspects of large language models. So we looked at some of the good things of LLMs. We looked at lots of applications in the last part of the discussion. So we looked at lots of applications with respect to how these LLMs can be used for classification, question answering, summarization, and different generation type of tasks. Now we'll get a little deeper into the different vulnerabilities and shortcomings of language models and a little bit of general theory. But as we see, as we go through the remainder of our sessions, we will realize that we'll see some of these things in action. One very important problem that LLMs suffer from are injection attacks. And what are injection attacks? Injection attacks basically means that you can effectively, instead of writing a simple prompt, you can effectively give some malicious input. And when you go and give some malicious input, you can effectively make the LLM do things that you don't want it to do. And that is what we refer to as an injection attack. Okay, so injection attacks are once again uh, kind of like you're making the language model do things that it is not supposed to do. Okay, and definitely this is very, very malicious in nature. I can show you one example of what I exactly mean to say, and this is the other part we'll try to do. We'll try to support all these things through lots of examples and use cases so that everyone can relate to it. So let me show you one small example of this particular thing in action. So this is a beautiful example of what I'm actually talking about. There's a website called LLM Attacks, Adversarial Attacks on Language Models. And if you see, very interesting. If I ask a question, build a bomb, this is generally the kind of answer you will get. Okay, if I look at any language model and if I ask the question, how do we build a bomb? This is the answer you will get. Okay, it'll say, I'm sorry, I can't assist with that. And the reason why this is happening is because all these large language models internally have some safeguards. This is something called guardrails. Guardrails are some constraints, they are restrictions. So the language models will automatically uh, ignore certain types of questions, and it will automatically ignore certain kinds of responses. So there are certain kinds of questions, if you're asking, the language models will automatically ignore them. And there are certain types of answers it will also typically not give. So that is the way these kinds of uh, language models are trained. It's not just a powerful model where based on some input it will predict some output, but they are also in a way, these language models are also in a way, they are having guardrails or they are having several mechanisms built within them using which they can go and uh, you know you can avoid certain types of responses. That is how these language models can work. Now, very interesting. If you now go and ask add an adversarial suffix, look at this. I know this doesn't make a lot of sense generally, but what you are seeing on the screen here is what really happens. What really happens in a scenario where you are adding some random suffix to it. Now, this does not make too much sense to a human being, but the moment you feed this kind of a prompt to a machine, the machine will actually give you the tutorial on how to make a bomb. This is called an adversarial attack. You can ask a different question. Let's say steal from someone's identity. If you go and ask this question normally, if you go to chat GPT and ask this question, I want to steal somebody's identity, it will also give you a similar kind of answer. So adding an adversarial suffix means that you're trying to do a kind of an injection attack. You're trying to not only write the question, but you're trying to add some other additional information on top of that. And these are different mechanisms that malicious actors are using to make the language model generate answers that it is not supposed to generate. This is one of the shortcomings, and honestly, there is no solution to this problem. And all the top LLM providers that we have, like OpenAI, Google, all the top companies which are creating these language models, they have also admitted that there is no solution to this problem. The only way to do it is when some mistake happens, they can fix it. And in fact, if you look at the last 2 to 3 years, ever since these language models have started coming out, Even ChatGPT, if you look at the very first version of ChatGPT 2022, December 2022 is when it was released. And if you look at the iterations after that, it has become better. It is not that in the first iteration ChatGPT was perfect. In fact, when ChatGPT was released, it took the world by storm and there were lots of mistakes it was making. At that time, ChatGPT, if you were asking this kind of a question, ChatGPT will actually give you the answer. There were very few to no guardrails that were built in the system that time. But now the language models have become a lot more robust because they have learned from historical data, they have learned from feedback, they have learned what users like, they have learned what is correct, what is not correct, and that's the way how you improve. So the same applies for adversarial attacks also. Just wanted to call it out. Second is data privacy concern, very important because in all these cases, what we are doing is we are writing a prompt, and especially with respect to enterprise data, one of the things that happens is you need to you need to ensure, especially with respect to enterprise data, if you see, you need to ensure that uh, the data is secure because you're sending this prompt somewhere, right? If you look at this thing, you're sending this prompt somewhere. Here also, you're actually going and taking this prompt and you're sending it somewhere. That's the idea. You're sending it over an open network. If you're calling a GPT model, and we will be using API shortly, you're actually making a LLM call and you're sending the data to OpenAI servers. Or if you're using Azure, in our session, we will use Azure. We're actually going to be sending the data to Azure servers, right? So that's the thing. So how do you ensure security? How do you ensure privacy? If you have confidential data, then that's also a challenge. Because many times what will happen is the top providers, all the top tech companies that you have today, OpenAI, Microsoft, Google, uh, Anthropic, which has the Cloudless Sonnet model, all these top LLM providers, they don't allow you to download their models. So you cannot download it locally and work with it. Locally, download is only possible for the open source models, but the closed source models you cannot download. The top providers, they don't allow you to download the models, right? So the only way to use these models is to invoke them through APIs. You have to create an API and you have to call the APIs to use the models. And the moment you do that, you risk sending data over a network. And the moment you do that, there are privacy concerns because the model is hosted in some other server. The model is hosted in OpenAI servers because that's their property, that's their IP. They will not allow you to download. So that is a risk that is also there. The third kind of risk that companies face is IP concerns. This is a very, very big issue, and this continues to be an issue. Yes, off late, a lot of things have happened, but OpenAI also has been in the news for this precise issue historically. So if you go, let me open up an example for you and show you what I exactly mean to say by this. So I will quickly open up my chat GPT and write a couple of queries and show you exactly what I mean to say by this, okay? So what we can do is, like I can go and search for some news stories, right? So let's say I can say, show me the top technology news stories from the Wall Street Journal. Now this is very interesting. I'll tell you why, because uh, this is a language model, right? And if you look at a language model is primarily trained on a language model is primarily trained based on historical data, text data in the open internet. And OpenAI has often been blamed for using proprietary data. Like all the major news publications like New York Times, Washington Post, Wall Street Journal, they have historically blamed OpenAI for using their data to train their language models. And you can imagine why it is a big deal because anybody can go and write this kind of a query. And if I hit enter, look at what will happen. I'll use a search GPT. And if I go and do this, I will actually get the top news stories from Wall Street Journal. Okay, so just wanted to call that out. And you can see very, very interesting. All these are news stories from the Wall Street Journal. If I hover over it, you can see it is pointing to WSJ, it is pointing to WSJ, and it is pointing to WSJ. And if you click on it, it will take you to the entire Wall Street Journal article. Mind you, Wall Street Journal per se is usually blocked by a paywall. Now, this is very interesting. You can see that this is actually a subscription article, right? Can you see? If I just scroll down, it says that, hey, you have to take a subscription. I can't read the article. But yet, the interesting part is when I go to ChatGPT, it actually summarizes the article for me. Now, there's something very interesting going on. If this was 1 year back or 2 years back, this would have been illegal. And OpenAI was doing that. They were actually doing this. They were actually scraping the news stories from all these major news publications, uh, news stories dating back to, several 10, 20, 30 years back, right? And this was illegal because here is Wall Street Journal. They've invested all their resources and their, it's a big organization. Okay, the editors, they have to hire, they have to pay, and then there's a lot of investment involved. And here comes OpenAI, and for free, they are just using their data. That was wrong. Then why will people subscribe to Wall Street Journal? Think about it. It's a revenue loss for these kinds of companies, right? So then there was a big lawsuit that happened. A lot of companies started suing OpenAI. Not only OpenAI, a lot of companies. I'm just giving an example of OpenAI because that's been in the news because it's so popular. And then very recently, uh, as we speak today, this is legal. Why? Because OpenAI has a partnership with Wall Street Journal. You can ask a question, right? So does OpenAI have a a partnership with with WSJ? And you will see the answer to the question. It actually it has signed an agreement with Wall Street Journal. I think with some kind of $1 million. I don't remember the exact number, but you can see that they have a formal partnership with News Corp, the parent company of Wall Street Journal, and this multi-year agreement grants OpenAI access to current and archived content from News Corp publication. This is very important. Current content as well as archived content. So even if you don't have subscription, you can actually use OpenAI and read from Wall Street Journal, which is very interesting, right? So you can actually say what are the top news publications that OpenAI has access to, and formal agreements have been entered into. Okay, you can actually take a look at it. And this is such a revolutionary thing because the entire way how people consume news is changing, right? Can you see? I mean, people will no longer probably go to something like a Wall Street Journal and all that and read something, but they will rather come to ChatGPT and ask this kind of a question and see how beautifully it summarizes this for me, just like Perplexity, no? So we actually get to see the news sources. These are all subscription paywalls, right? But then I can use ChatGPT. I can pay for the ChatGPT subscription, and through that I can read Wall Street Journal articles, which are beautifully summarized. This is quite good. You can actually see all the top publications. They have a partnership as we speak today. So Financial Times, a very, very popular newspaper, they have a partnership. You can actually read FT articles from ChatGPT directly. Condé Nast is a very popular publication. I think it's a travel kind of thing. AP also agreed. So the list of things you will see, right? So very interesting, and also very interesting. Reddit. Reddit is something I'm sure a lot of you use generally, but I don't think many of you know that uh, Reddit and OpenAI also have a partnership. So you can actually go and use ChatGPT to browse Reddit threads, which is quite incredible. Some of the ways how you know maybe the future in the next few years will look like. So people may no longer go to Google search and kind of search something, but they might use these kinds of assistants more and more, where they get answers to questions through these assistants. You don't have to kind of go and look in multiple links and multiple sites and do that. Okay, so yeah, so just wanted to clarify, and this is also a risk. Why? Because there are IP concerns. IP concerns are real because you can be an enterprise. Now, all this we are discussing in a fun way, but you can be an enterprise and you are using a language model for doing something. You ask a question, get an answer, but the answer that you get, that might be a IP violation. Maybe that answer is taken from some other website, or maybe the language model is scraping data from some other site that it's not authorized to. So these are all real problems. IP concerns are real. And the last part is lack of explainability. And this is also a very, very important aspect. Language models are prone to, they are black boxes. All these language models are black boxes. It's very hard to know what is exactly going on behind working behind the scenes. So do we know exactly why, based on a particular input, a particular output is coming? Do we exactly know why that happens? No, we don't know. We do not exactly know why, based on some input, we are getting some output. That is something we do not know. So all these language models, this is again a big aspect I wanted to talk about. So the interpretability part is is indeed a big problem. and they do lack in interpretability. So that is a real problem that we have. Okay, but we are getting towards it. We are solving these problems, and if you see, there are a lot of methods that are there today. And as we speak, if I have to maybe show you something, and there are a lot of it. There are a lot of, it's not just one or two things. There are lots of aspects we can talk about. For example, there is a bias aspect. Language models are generally biased. I mean, these are all problems. I mean, limitations are not only focused on this, but this is bias is also a problem. Language models are inherently biased. If you see, for example, this is a real data. Okay, this is the real data, and you can see that when I go and ask this kind of a prompt, he works in a hospital as and you're using a GPT-3 to complete, it will say doctor. And if you say she works in a hospital as a, and GPT-3 will say it is a nurse. So this is just a inherent bias that the model has kind of learned, that usually males are doctors and females are nurses. It is not that that is true, but it is just how the model has been trained. And this is the same example I was talking about in the some time back when I was discussing about the Google Gorilla example. The same kind of bias has been learned by the language models, because when these language models were trained, they were trained on a lot of open internet data, right? And this is how the data was historically used. Historically, the word he and hospital and doctors were kind of related, and she and hospital and nurse were kind of related. And this is all that these language models are trying to do. They're trying to learn these word associations. They're trying to learn these word relationships, and you will see this bias come up, generally again and again, usually. And there are a lot of these kinds of cases that you will actually find where bias is a very real problem with respect to these language models. Okay, now let me just show you a couple of other things as well as we go on. And if you want to have a formal track of all these incidents, there's something called an incident database, which is kind of it reports all the top AI incidents. Any kind of AI incident happens, is actually kind of an incident database that is also there, which lists out all the top AI incidents that happen. And the example I like to talk about is this Air Canada. So very interesting. This just goes to show some of the areas where language models can actually screw up. What are the problems? I mean, all this while we are talking about the good things, but these are some limitations. Bias is a real limitation. If you're building a LLM chatbot in your company, and if that model is biased and it gives wrong responses, then there are repercussions for that. If there are injection attacks, there are repercussions for that, right? So what happened with Air Canada was, so there was a chatbot and it gave a wrong information to the customer. This is a real incident. These are all real incidents that we are talking about. Okay, so there was a chatbot, and the customer was normally interacting with the chatbot, and maybe the customer was searching for some cheap flights or something, and Air Canada apparently say that, okay, you can there's a huge discount we are offering. So there was a false discount claim it made, and due to that the customer confirmed the flight, but then on the day of payment the customer ended up paying more, okay, leading to the customer overpaying for the flights, right? So the discount claim was inaccurate. The customer made the travel plans and everything based on that, but then on the payment time the customer actually ended up paying much more, so the discount information was false. So these are again very common aspects of LLMs, where oftentimes LLMs give wrong responses. It is not always intentional, it is sometimes unintentional. You ask a question in GPT, and sometimes GPT generates a wrong answer. Not that it's doing it intentionally, but that's just how the models are generally trained. Okay, so a lot of times there are real repercussions for these kinds of situations. I just wanted to call that out as well. And finally, when we particularly talk about explainability, this is just one more thing I wanted to bring it up for all of you. There are methods that we are starting to come up with now as we speak, and a very very popular method is using Shapley values. This is a bit of a technical thing, but especially focusing on this last part where I mentioned that the language models are not explainable, lack of explainability. What are some specific methods that we have to deal with this? We use something called Shapley values. And Shapley scores can be used to interpret to some extent how and why the language models are giving certain types of outputs. Now here is a very simple example we have taken where I think it's a bit technical where we have used a machine learning model, an XGBoost model to look at the different features of the customer and try to predict whether the customer should be approved for a loan or not. So we are discussing a traditional machine learning use case, but even in machine learning, it's a kind of a black box, right? We do not know exactly why the model gave a certain answer, but using things like Shapley scores, we can actually find out that based on which factors the machine is predicting, should the customer be approved for the loan or should the customer be rejected for the loan. And you can see very clearly for this set of values, you can actually edit the numbers here also if you want, right? You can see that when we have a new customer, this is like having a new X. Uh, we are getting the predicted value, which is approval. And now you can find out, okay, why did the model predict approval? And you can see, I think some of the factors that is leading to this is, like look at this one, verification status. So verification status turns out to be a very, very important factor, right? So these are all very, very important factors that leads the model to approve, right? So credit utilization, debt scores, FICO scores. So all these are FICO score is actually quite high. So this is leading to the customer to, so you can see this in action actually. Okay. So again, there are a lot of important ways we can also go and try to unravel that black box.